Welcome to the seventh example in review of statics. The question reads, determine the horizontal and vertical components of reaction at pins A and C of the two-member frame. Okay, in terms of notes or in terms of givens, we're not given much, so we're just going to do similar to the last question. We're just going to say diagram, so we can refer to the diagram in the picture, or we can even refer to the free body diagram, which will have most of our information to solve the question. There is one note, however, in this question, and that is that this structure attached to this is the beam of like interest, basically, but this structure that's attached to it from point B to C is a two-member frame, or a two-force member, basically. And what does that mean? Well, that basically means that this structure will only have two forces equal and opposite in magnitude. So, for example, if this is the force FBC, this force will be the other one in the structure, and it will be negative FBC, right? And similarly, the components, or I should draw it like that, but like CX and CY are going to be equal to BX and BY in magnitude. Not in direction, but in magnitude. They're going to be opposite direction. But the main takeaway is that this structure will only have two forces acting equal and opposite. And that's very important for our calculations later on. So we're going to put our notes. So two-force member, or two-member frame. Perfect. What are we looking for in the question? What are our unknowns? We are looking for, we'll call them the forces AY, AX, CY, CX, and I'll probably forget, so I'll put this now. Our coordinate system's like this. Okay, we move on to the free body diagram. It'll take a little bit of time to draw, so bear with me. Let's make this one smaller, actually. Perfect. Okay. This is 3 meters. This is 3 meters as well. This is point C. This is point A, and this is point B. Now we can move on to our forces. What external forces does this structure have? Well, I see a distributed load, and if we multiply this distributed load, which is newtons per meters, if we multiply it by 3 meters, we're going to get rid of that meters, so like that, and we're going to get the force. And where is this going to act? It's going to act at the center of this rectangle, basically, which is 1.5 meters away. Perfect. And it'll be 600 newtons in magnitude, so 200 times 3. So this is 1.5 meters, and it's 600 newtons in magnitude. Okay, what other forces do we have? Well, I see 3 pin connections, so we're going to have 3 forces there with X and Y components. And as we said before, if this is our force FBC, and this is negative FBC, we can split the components of this force up. I see this is a perfect square, basically 3 meters by 3 meters. Therefore, if you look at the diagonal, I know I didn't draw it properly, or like to dimension, but this angle right here is a 45-degree angle. So what we can say that this component of the force FBC is cosine of 45, and then this one is FBC sine of 45. And then on the other side, for at point C, we can say, we don't even need to do the sine and whatnot. We can just say that this is CX and this is CY. And the reasoning behind this is all we need to do now, since we know that FBC, for example, sine 45, is equal in magnitude but opposite in direction to CY, if we find FBC sine 45, this component, we basically found one of our answers, because we know it's equal to CY, and similarly for the X component, right? Okay, perfect. What other force do we have? We have AY and AC acting at pin A. Okay, AC, or AX. Okay, I think we have everything to do our summation of we'll start with summation of moments. Why? Because if I take the sum of forces, like it's the same steps in the end of the day. Like it'll just take longer to solve. Like you'll just have to plug in more equations. But if you go directly to sum of moments, what will this allow me to do? This will allow me to find FBC. Because if I take the sum of moments around A, AX goes away, AY goes away. I have this force that I need to take account to, and I have this force that I need to take account to, FBC sine 45, right? So I'll only have these two. I can easily find one equation, one unknown. I can find FBC. What can I do with FBC? Well, then this is just a game plan. We'll go through the calculations. But just so you understand, if I find FBC, I've basically solved the question, because all I need to do is take a sum of forces in the y direction, and I'll find AY, right? And then I know FBC. So I also know FBC cosine of 45. So I'll just take a sum of moments or sum of forces in the x direction as well. And that will give me AX, and that's basically your answer, because FBC sine 45 and FBC cosine 45 are, in fact, CX and CY, as we've established previously. So we will run through all this fun. And if you didn't catch all that, you hopefully will right now. So some moments about A. Okay, as we said, if we take counterclockwise to be positive, we sum the moments about point A. We have a negative moment, I believe, right? A negative moment caused by the 600 Newton force times 1.5 meters. And we have a positive moment caused by, I don't have space. We have a positive moment caused by the force FBC sine 45, and it is a distance, 3 meters away from point A. If you solve for FBC, you are going to get the FBC is 424.26 newtons. Quickly, to find FBC sine of 45, and let me keep everything in frame, FBC sine of 45, and FBC cosine of 45. Sine of 45 is square root 2, I have the number here. It's 300 newtons. This ends up equaling 300 newtons, and this also ends up equaling 300 newtons. Okay, well, what do I know about this? Well, I know that FBC sine of 45 is actually equal to CY, and I know that FBC cosine of 45 is actually equal to CX. And those are two of my answers. Okay, well, how do I find AX and AY? Well, all I have to do is take the sum of forces in the X and sum of forces in the Y, and I have my answer, because these are my Y forces. I don't know this one, I know this one, I know this one. These are my X forces. I don't know this one, I know this one. If you take, or actually do it, sum of forces is step 5. If I take the sum of forces in the X direction, I will get the AX plus FBC cosine of 45. If you solve for AX, you are going to end up getting that AX is equal to negative 300 newtons. And that basically just means that AX actually acts in this direction. We guessed wrong. Basically, AX actually acts in this direction. If we take the sum of the forces in the Y direction, we have AY minus 600 newtons plus FBC sine 45. And from this, we end up getting that AY equals 300 newtons. So we guessed the direction properly. And those are your 4 answers: the reactionary or the vertical reactionary force at AY, the vertical reaction force at point A, the vertical reaction force at point C, as well as the horizontal reactionary forces at point A and point C.